Hello and welcome back to Steam with Steve. Today we're going to go through an introductory lesson where we're going to explore why Python is so awesome for computer scientists. It's a really good language to start off with and gives you some really interesting ways of understanding core concepts. So let's jump on in. So to begin with, when we look at Python, these are the learning objectives that we have. So we want to understand the basic concepts of Python programming and its real-world applications. We're going to learn some fundamentals of binary code and ASCII, and then write your first Python script with Hello World, and then appreciate the importance of this programming language compared to some of the other ones that are out there. So when we look at a computer, it's only as smart as the person that programs it. Now, obviously with AI, it's a little bit different now, but the actual programs that run behind the scenes have to follow this really clear syntax and semantic structure. So if you tell a computer, for example, to give it to Steve, and it clearly says Stephen on the label, most of the time, if a computer is following a program, they won't understand what needs to happen. So computers are really good at following instructions, but they're bad at thinking for themselves. So making sure that the instructions are clear is what the job of a computer scientist is. So to start, let's think about what a program is. So a program is a list of instructions telling the computer what to do. It must be precise, and its semantics and syntax must be correct. The semantics is the logic, and the grammar and spelling is the syntax, which is the structure. So is the semicolon in the right spot? Does it have the same layout? Is the indentation right? Those are all syntactical issues. Programs will follow three main control structures. So the sequence, the selection, and the repetition. So sequence is the step-by-step things that happen. Selection is the choice, so does it need to go left or right? And then repetition is a loop. So following the same thing over and over and over. So the powers of two is super important for computer scientists. We need to make sure we follow this. So we need to remember these off by heart. So 1, 2, 4, 8, 16, 32, 64, 128, 256, and 512. My advice would be to learn these as quick as possible. They're super useful and very important. Righto, so to start, we need to translate. So if you were given that, would you be able to translate? And most of you should be answering no. So that's actually written Urdu. What about if I wrote that? And same thing, that is in Punjabi. I personally would be able to do that. How about that one? So that's actually written in binary, so the computer understands it. What about that one? Again, probably should be struggling with the Georgian. Honda, there might be some people out there might know what that means. It's actually in Afrikaans. Hey, for our New Zealander friends, it's in Maori. And then that one, which is Chinese. And then if I wrote it like that, chicken. Everyone should be able to read that now watching this. So that's in English. So when we have context, that's the whole point of a language, is that we understand what it means compared to other phrases and nouns and words that we put together. So it's very important that we have this context of what it means. This is what binary is for a computer. So we need to make sure that it understands what the zeros and ones mean and how does it link that together so that other computers can understand. The computer understands only on and off, right? So it understands binary. So it's true and false, 0 or 1, or on and off. It's really important that we're able to translate between these two. So here's a little joke video that I found from Futurama. Bender's freaking out because he doesn't understand. He's dreaming about ones and zeros. Wakes up. Fry comes, helps him, and then they work out who doesn't really exist. Bad joke, but it's pretty useful, right? So computers only understand zeros and ones. So when we look at binary code, it's a series of false and trues. That's what every single one of those are. So it's either on or off, like a little light switch for each of those parts. So we describe that using zeros and ones. So 0 for false, and then 1 for true. This is how computers understand with a technology called ASCII. So ASCII tables have been around for many years. It basically stands for the American Standard Code for Information Interchange. So it was used when networks first sort of started coming on the scene. And it's a binary number that represents a single character or a communication code. So It uses 1 byte or 8 bits. So basically those bits all sort of line up. And there's 256 different options if we use the full 8 bits for the different codes that are available. So for example, if we have 0101, 0011, that actually represents a capital S. And I've included the table over here on the right so that you can sort of see where the uppercase and lowercase letters are. The numbers sort of come first, then you've got the uppercase characters and then the lowercase characters, and then also the punctuation sort of symbols that are included as well inside ASCII. Yeah, by using 1 byte, that's a lot. It's a very small measure of memory, but then it's also consistent when you're sort of changing between different computers. So our first goal is to try and change your name into binary. Here's the binary table. Please pause the video, have a little go, see how you go. Awesome, so you should have had a bit of a play there. What you should have found, for me, Hendo is my nickname, so I'm going to convert it into that. So I'll do H, come down to the table, and then go 01001000. Then I would go E, so 01000101. Then N gives me 01001110. D gives me 01000100. And then O gives me 01001111. Now that gives you a pretty useful way of sort of changing in between the two. You can also cheat, which is what I actually did, so sorry about that, guys. If you click on this link there and you open it up, hello, how are you going? You can see it converts into binary straight away, which is pretty cool. So this encoded string down the bottom here is actually the binary code that the computer understands on the other end. Cool. So jumping back in, hopefully there's a little link there if you want to play around with a bit more. So why don't we program in binary code? What's the problem with using a whole heap of ones and zeros and just bashing it out like that? Well, there's a whole heap of different reasons. The main ones that sort of come to mind is the readability. So trying to work out your name inside of that does get a little bit harder. It's easy to make an error. So if you put 1 0 in the wrong place or a 1, totally breaks the code. It's inefficient to write because you've got to spit out a whole heap of 1s and 0s. Humans don't speak in 1s and 0s, not most of us. And if you have to do scale, so for example, if you had to build the whole of Fortnite just using the 1s and 0s, and if you imagine, I think Fortnite's brought up to about 100 gig. So there's 100 billion bytes all sort of lined up trying to get in, which is a lot of time to do. There's also programming libraries, so drawing in from other programs that people have written that you miss out on. And then it's also machine dependent. So if you want to run that bit of code on a PC compared to a Windows or on a PlayStation, the code only works depending on the machine that it's been built with. So there's a lot of sort of problems with that. So Dijkstra's got this really cool quote that I love, that has been with me for many years. So the art of programming is the art of organizing complexity. So taking something really complex and then breaking it down into sub-modules so that you're easy to program. And then I found this little funny program joke here. So real program is code in binary, and the guy's only got 3 keys. So 1, 0, and enter. Notice that he doesn't even have a delete key because that's how intense this person is. So what is a programming language? You might have heard of all these different ones around. So Python, C, C++, Lisp, Java, PHP. There's a whole heap of different languages that are out there. And it's basically a set of conventions for communicating an algorithm. So its purpose is to specify an algorithm in the data, communicating it to other people, and then that helps you establish the correctness of what people understand. So by having this programming language in place, it does help you understand what it means so other people can pick it up and get their head around it. I then found this cool little video that we're going to watch together. It goes through the history of programming. So Fortran, very old language, but awesome. Sort of started it all off. Then you'll sort of see it increase in time. Then you got other ones like COBOL, BASIC. Lisp. The Fortran was sort of the main one back in the day. What you should see, basically what happens is there's a point when all of a sudden Fortran sort of loses a bit of favor. That's when Pascal comes in. Pascal is sort of a bit more object-oriented programming. Everyone sort of jumped into that ship. And then down the bottom you can see C slowly sort of creeping in now. And then COBOL sort of went to the side, which was more of a business language. And then what happens is Pascal just sort of jumps the queue. And then what you slowly see is C sort of comes towards the top here, which is pretty cool. And then you've got other exotic languages like Lisp, which is sort of more of an artificial intelligence language. And then SQL, obviously, way down the bottom there, which is sort of starting off, which all your databases are built on. And all of a sudden, sort of C takes control because a lot of the operating systems started getting built in C. And then you'll slowly see Fortran sort of die off as a language, but still people need to use it because a lot of systems were already built using it. So that's where a lot of programmers sort of make their money as legacy programmers. Then you'll see sort of Ada coming up, but then that sort of fizzled out after a while.
Recognizing the urgent need to protect the digital world from these mounting threats, experts used code to develop encryption and intrusion detection systems. These cyber guardians sought to fortify the digital fortress against those who would wish to exploit it, which was going to be increasingly necessary.
And then what happens at this stage here is when the internet sort of networking sort of took precedence, and a lot of people sort of jumped on that bandwagon. So a lot of cybersecurity sort of started happening with the internet, ARPANET, and a lot of the back-end sort of stuff, which is why C started becoming a lot more prevalent. And as you can see, it's really sort of taken a real big chunk of the market through the early 90s. So basically ARPANET was the initial internet. And then building from that, it sort of extended it a bit more compared to the others. Then some neat stuff started happening. So Visual Basic, which is used for Excel and whatnot. And then you started seeing other languages like Java and JavaScript, SQL sort of coming to the front. And then down the bottom, you can start seeing Python sort of slipping in there, which is kind of cool. But you see Java, which was originally built for cable TV, started taking a lot more precedent because it was able to work on many different areas. And then JavaScript obviously helped with online with the internet. So Python wasn't so popular in the early 2000s yet, simply because it wasn't, the need wasn't there yet. Compared to other languages like Java and SQL, obviously with all the database stuff that happened. And then, like we said, Ada, which was a pretty important language, is sort of backed way off. You can see Ruby popping in there now, which is kind of cool. So Ruby was an online language for the internet. And then Visual Basic also dropped down. But this is when it starts getting kind of cool. People starting to see the value of Python, which slowly pulled up. PHP is also quite prevalent. That was a lot of the websites were made. Facebook, for example, at the start was done in PHP. And then here's where the Python starts sort of going a bit harder. And then also C# as well, which is took over from Visual Basic. So that was Microsoft's answer to Java. So it's C# and Java are very similar. And then this is where I thought was pretty cool. So Python starts creeping up a bit more, and sort of takes over with all the different things that it can do, all the machine learning and whatnot. Plus it's easy easy to use compared to other languages. And this is where it gets really cool. So suddenly Python becomes a more dominant language and becomes the number one, which is pretty cool. And then that's basically because of all the machine learning, its flexibility. It's very easy to learn to start as a starting off programming language. Yeah, some really neat stuff that you can do with it. You'll see that Java sort of drops down a bit, but still is relevant. With JavaScript jumps up a bit more here as well. But particularly with all the machine learning, the only equivalent to machine learning that you can do is with a language called R. But that's why Python's pretty much the main sort of go-to. You'll see there's a huge resurgence in JavaScript here, just simply because of all the web stuff that was starting to be developed. Which is pretty cool. But yeah, there's some pretty neat. This is a pretty neat infographic that goes through all the different things that happen. So hopefully that's giving you some insight why Python's pretty useful. It is the number one, in my opinion, language to learn to start off with, particularly with entry-level robotics. You can do that sort of stuff with it as well. And then yeah, hopefully you enjoy. So how do we get a computer to understand us? Really important. So the first step is we have a high-level programming language where we write in something that looks English-like. And that's what C, Pascal, Java, and Python all sort of are. It then goes through a thing called a compiler that then converts it down to the zeros and ones, which is sort of more the machine assembly language that a computer understands. So Python's a little bit different. It doesn't have a compiler directly. It actually has to go through another step, which we call an interpreter, to get down to it. So there's no 100% right way when you're learning a language. All programming languages have their advantages and disadvantages. I personally think it's like learning a martial art. Good old Bruce Lee had this really cool quote. So absorb what is useful, discard what is not, and then add what is uniquely your own. That's basically what you try and do with this. So why did we choose Python as your first language? Well, it's super powerful and fast. It plays well with others if you're trying to interact. It runs everywhere, so any computer can run Python. Friendly and easy to learn. It's open source, so you don't have to pay for certain things. And it's really cool, in my opinion. So what is Python? Well, it's a programming language that is both simple and easy to learn for beginner programmers. And then it's also scalable to some very large real-world projects. We'll be using Python version 3. I think that the current edition is 3.12. And basically, there's some whole heap of different systems out there that use Python. So a lot of the warehouse robotics uses Python. Google's Spider and search engine uses Python behind it. A bit older, but Battlefield 2, which was a game, does it. And then also NASA. So how do we install Python? Basically, all you got to do is click on this link down here. So python.org downloads. And then what happens when you get there, you click on the download Python 3.12. My advice when you're installing it, just make sure you install the add-ons. The pip installer helps as well. And that can sort of assist when you're doing some later things when we do Pygame. So the interpreter versus compiler, that's a main question that we have. So interpreter is like a conversation and it converts one statement at a time. So it's really good for simple programs like what we're going to do in Python. When we compare that to a compiler, which you may have heard before, it's like making a book. So it converts all the statements down to the zeros and ones, and then it's really good for complex programs. So if you're trying to build something like Fortnite, you want to use something like a compiler, which is more the sort of the C engine, so C# or C+, whereas an interpreter is better for short, sharp sort of conversions that you'll be doing. So Python doesn't run as an interpreter or compiler, it's an interpreter. So it runs the code line by line. You can make it look like a compiler by writing a script, but what actually happens is it converts it into a C language and then it runs into a compiler with different library accesses. So when we write a script, it basically will feed into the Python interpreter. So, and then this is what IDLE is. So IDLE stands for an integrated development learning environment. And then we use that to run our Python test code. So how do we access the interpreter? Super easy. Basically, you do a search and you open up IDLE, and then you'll run that. So on Windows, if you go IDLE, there it is there, and you just literally click and go. When you're running it, it's super easy. If you type in different commands, so if I go 3 + 3 and then press enter, it gives you the answer straight away. If I want to do more complex math, no, I divide by 4 and press enter. That's what happens there. So that gives you some pretty good insights into how the Python interpreter works. So there's an ancient tradition in all programming languages where you learn Hello World, and it's pretty simple. Basically, you're going to learn how to print out Hello World inside of IDLE. So the way that you do that is you go here and you go print, open brackets, Hello World, then press enter. And that gives you the response. So anything with these 3 lines is something that's been injected into the program, and then it's trying to run that inside the interpreter, and anything written in blue is the output. So that was your first version of Hello World, which is pretty cool. Hello World in other languages is a little bit more complex. So to write exactly the same thing in C, you needed to do this using a main line. In C++, this is how it looks. In C#, this is what it looks like. In Delphi, a little bit simpler, but still not as elegant in a one-liner. In Java, it looks like that. And Visual Basic.NET, it looks like that. Then Pascal looks like this, which is a little bit harder. So the whole point is Python's very easy to get the same sort of output, and also the coding that you do will be a lot simpler to get your head around while starting off. So the conclusion questions to ask: how can your understanding Python impact your interaction with technology? In what ways can programming be applied in other subjects or hobbies? And then how does binary code serve as the foundation for more complex programming languages? You should be thinking about these things. There's a quick little Kahoot there that you can play. And then the other thing that I'd highly recommend is Code Combat. So logging into this link here, can use the class code that I've given there, but by doing this course before I sort of jump into it, it will give you some really good insights on how to use Code Combat. I've given a YouTube tutorial on how to do each of the stages inside of Code Combat, and I'd highly recommend having a go at that first before we go into my version of the teaching of Python. It'll give you some of the fundamental stuff, and it's a really fun RPG game that you can play. So basically, you'll have little games like this, and you'll have to move the hero around using the different methods that are available to you. Cool. So that's everything from me for this lesson. Hopefully you've learned something along the way about how cool Python is and giving you some insights. Highly recommend getting straight into that Code Combat, and there's also a Kahoot attached to this that's linked down the bottom. So if you enjoyed this video, make sure to give me a like and subscribe. Really helps with the YouTube algorithm and getting the message out there that how to learn Python isn't so hard. And hope you've enjoyed. Thank you very much. See you next time on Steam it with Steve. Adios.